Hi everybody, welcome to this presentation. First of all, my name is Skov. I'm product manager for heat pump in Johnson Controls under the brand called Sabroe. First of all, Johnson Controls is globally represented with multiple brands, Frick, York, Sabroe, just to mention some. With regard to the European footprint, we have more than 1,300 employees in Europe, multiple manufacturing sites, and more than 700 technicians in the field. Going back to me, product manager for heat pumps. Prior to this position, I was working in the engineering and R&D development, working on improving and putting new heat pumps to the market. So heat pumps has been a central part of my last 8 years at Johnson Controls. And I'm really impressed, the commitment to really put new products to the market, carry out enhancement, but also the market adaptation of heat pumps, figuring out new ways to implement heat pumps in existing system, but also thinking them into new systems with the constant target to improve efficiency and drive decarbonization. 4 years ago at Chilventa, we stated that we need to act. We have no planet B. It's now more relevant than ever. This presentation about heat pump, I'm actually going to start up talking about cooling, because cooling requires approximately 20% of the world electricity. That goes only for cooling purpose. And for that cooling purpose, we have a large amount of excess heat that's unused currently. Meanwhile, energy for heat is the largest, it's fairly loud. Energy for heating purposes is one of the largest energy end use, nearly accountable for half of the global energy consumption. So 20% of the electricity goes to cooling purpose with a lot of waste heat, and then heating accounts for approximately 50% of the global energy consumption, split approximately 50-50 between industry and building. So when I can't we do something about it, Okay, so going into heat pump, this presentation with the title of Driving Decarbonization with Sabroe heat pumps, we're gonna talk about some of the multiple benefits in the market, both from the infrastructure, from the end customer point of view, and all with the target of driving decarbonization. So first of all, security of supply, dependency on fossil fuel. Statement here is that we must ensure a reliable, secure, and affordable supply of energy to European consumers. When we see customers that evaluate new heating systems, we see multiple drivers in this evaluation, some of them being climate, sustainability, the business case, and also the security of supply. Climate touches upon what is the greenhouse gas emission for this heating system. Sustainability, what is the optimization of implementing this system? What is the optimization compared to other systems? And the business case also with regards to the optimization. What is the total cost of ownership? There's a first cost in the equipment, there's a cost to operate, and what is the business case? Looking towards heat pumps, the business case is different. It's a larger first-time investment, but a lower cost to operate. But taking into account the lifespan of the product, the cost to operate generally makes it a really good business case. Last part being the security of supply. With recent event, we experienced a significant focus on security of supply, simply because what happens if our normal practice for heat production isn't possible anymore, or at least very limited? Therefore, Repower EU. So Repower EU is the European Commission's plan to make Europe independent on fossil fuels way before 2030. So Repower EU covers both reducing energy demand, acceleration, clean energy transition, improving energy efficiency, and also diversifying energy sources. And heat pump actually feeds into all of these bullets, also identified in the plan in the Repower EU, where there's the statement of doubling the rate of deployment of heat pumps. Next part being the electrification of energy systems. We briefly touched upon diversifying energy sources. Electrification is a big part of this. Electrification has become a popular term in renewable energy systems. And the reason being that electrification, amongst others, covers the transition of replacing fossil fuel system with energy systems that use electricity. And electrification has been identified as one of the drivers, or at least one of the potentials to alleviate the impact of climate change simply because of that. And what is the link to heat pumps? So currently, a lot of the heating demand is fulfilled by fossil fuel in boilers. This transition can be switched over to heat pump, also fulfilling the electrification. Heat pump uses electricity to provide heat, therefore feeding into the electrification, but also optimizing systems and reducing the energy demand. Which leads to the next point. Increasing energy efficient and decrease energy consumption needs to be top of everybody's mind. The statement here is that the greenest and cheapest energy is the one you don't actually use. Recent studies show that in Europe we actually have more waste heat available than we actually have heating demand for our buildings. Problem here being that the waste heat is available at a lower temperature, or a temperature that doesn't match the heating demand. But that's another benefit with the heat pump. Heat pump can utilize waste heat at various temperature level, boost it to the required temperature that feeds into the heating demand. Looking here at the example to the right from the white paper, Strengthening Industrial Heat Pump Innovation, Decarbonize Industrial Heat. So this is looking at a process, could as well be district heating linked to utilizing waste heat from various sources. At the top, we have a fossil fuel-driven system. So to provide 100% process heat, we need to put in more than 100% energy coming from fossil fuel. And then at the end, we have the waste heat. The purpose with the heat pump is to capture this waste heat, feed it back into the system, feed it into the heat pump, and then putting in electricity to drive the compressor, and thereby providing 100% process heat with only 25% energy input. So the purpose here is reduce energy consumption, reducing it down to 25%, delivering electrification where green sources for electrification can be used, and also utilizing the waste heat, keeping it in the system, also benefiting the CO2 emissions. So here, heat pump can be used to utilize waste heat or other sources at various temperature levels. Waste heat in general needs to be used, and it has multiple benefits when linked to heat pump. In general, with ammonia heat pump, the rule of thumb states that for every degree you increase your evaporation temperature, you increase your capacity by 2 to 3%, and your efficiency, your COP, by 2 to 3%. And since waste heat is available both as low, medium, and high temperature in the range from 15, 20 degrees all the way up to 80 degrees, this can really have an impact on the heat pump. So if we have a fixed size of the compressor and we increase the evaporation temperature by 10 Kelvin, we actually put out 20 to 30% more capacity for the same compressor. And also we increase the COP by 20 to 30%. So getting more capacity from the same compressor means that we lower our first-time investment in the heat pump. Increasing the efficiency means that we lower our cost of operation, in general making the positive business case for the heat pump with the total cost of ownership. Also linked to this, heat pump utilizing waste heat has multiple benefits towards the road to net zero. Reducing energy need, as seen here, utilizing the waste heat that is available anywhere, enabling electrification, and also optimizing energy systems. And then our portfolio. Sabroe heat pump. We have a large installed base with more than 400 heat pumps, which has really been ramping up the last 3 to 4 years. With more than 30 different models available, developed throughout the last 10 years, capacity from 300 kilowatts up to 7 megawatt, temperatures up to 95 degrees, and we use the natural refrigerant ammonia. We use ammonia due to the global warming potential being zero and the ODP also being zero. Other than that, ammonia, due to the properties of the refrigerant, offers a really high efficiency for the heat pump, which is one of our key focus area when developing products. Ammonia being natural, also widely available, widely used in the market as is currently, and we also call it a future-proof refrigerant, which is with very little risk of being regulated. Since we develop equipment that will last 20, 30, 40 years in the market, we need to base it on a refrigerant that we know is going to be available long-term. So the product illustrated here, starting at the bottom, we have the heat pack. Heat pack uses a reciprocating compressor. It's available in both 50 and 60 bar, and with capacity ranging all the way down from approximately 150 kilowatts up to 2.5 megawatt. Now I stated 60 bar, but starting of next year, this will actually also be a release in a 65 bar version where we continue to push the temperature upwards, now capable of delivering 95 degrees on this platform. The heat pack is a single-stage heat pump that can both use water-cooled evaporator, but also cascade evaporators that can easily be installed into existing cooling plants. The next product is what we call the dual pack. It's a two-stage heat pump made to utilize low temperature sources and lift it to a high temperature supply with optimum efficiency due to having both a low stage and a high stage compressor. So heat pack for lower lift temperatures, dual pack for high lift. At the top, we see a heat pump utilizing screw as the compressor, a screw compressor. This is available in 40 and 63 bar, and we have capacities up to 7 megawatt. But as we always says, it keeps getting better. The future is looking even greener. We are doing heavily investment in developing products, enhancing our capability to support the market and bringing the right products to the market that has been verified and tested in our test center. So we are currently, as we speak, upgrading our test center capability to test the heat pumps for the future. At the top here, we see a new heat pump, which is called the HiCap 273. HiCap is short for high capacity heat pump and is the start of our new series of heat pump utilizing screw as a compressor technology. This is the first and smallest in a series of 6 heat pumps, so 7 megawatt. At the bottom here, we see the largest compressor that's going to be used for this platform. We have it on the display in our booth as well. It's a compressor capable of delivering up to 25 megawatt, still using ammonia as refrigerant. So with these products, of course, we need to invest in our capability to continue to test and develop and verify products prior to putting them to the market, similar to all our previous products we have developed. Since heat is a critical demand and it feeds into requirements for high uptime, we need to carry out this investment prior to releasing it to market. We have this big compressor at display in Hall 7, booth 329, and please come see me, visit the booth to hear more about both the 407 and also the new heat pump family HiCap. Thank you.